We're going to do exercise 1 of problem set 1. In this exercise, they tell me that I have a network with n nodes, and in the first question, they ask to calculate the number of all possible links if the network is directed and if it is undirected. So let's see how to solve this exercise. So remember that the number of possible links, if I have a set of n nodes, okay, in general, n nodes are the combinations of, if I have to make a distinction if the network is directed or if it is undirected. For directed networks, I think it's easier to understand, because for every node here, so for instance, let's take this node, I have n-1 nodes to which it can connect with a directed link. Okay, so these are all the possible links that I have. And for another link, another node, okay, if I choose this other node, then I have another set of n-1 nodes that I can link to. So if I repeat this process with all the n nodes of the network, then I'm going to have a total of n times n-1 links. Okay, these are all the possible links. And for undirected networks, then what we have is that we must consider, instead of all these possibilities, we have to divide by 2 this number, because for every pair I'm going to consider this link and also the opposite in the directed version. But in the undirected version, these 2 links are the same. So really, I'm only gonna consider the link that goes from each pair. So it's n times n-1 divided by 2, which is also a combinatorial number. This is exactly the combinatorial number of n over 2, which is the combinations that we can take of n elements taken 2 at a time. Okay, so that's the solution. Now the second question asks if G is an undirected network. Okay, so we are assuming here that G is undirected, and they tell me that it has 50 nodes and 900 links. What is the density of this network? So if we compute the density, remember that the density is just the number of links divided by the possible number of links that it might have. So this is the L max, okay, that we computed before. So in this case, it would be 900. Well, since this is undirected, first of all, since this is an undirected network, then I have to use this version of the possible number of links. Okay, so if I divide by this number, is like dividing by n times n-1 and multiplying by 2 times L. So this is the expression for the density. And if we substitute these numbers, 50 and 900, then I'm going to obtain, yes, it's going to be 0.73, which is 7346, which is more or less 73.5% of the links are present in this network. This is a rather filled network, okay? This is quite dense. And if the network were directed, then instead of using this formula, okay, with this number, I would simply have to divide by this number, which is the maximum number of links for a directed network. So in that case, the density would be exactly half of it, okay? So the number of links is exactly the same, because it's 900, that's what they tell me. So in this case, the density would be half of this number. Okay, so it's L divided by n times n-1, which in this case it's equal to, let's see, it's 0.3673, okay, which is approximately 36.7%. Okay, that's it. So that's the value of the density in these 2 networks. Now the third question in this exercise, they're asking me for an undirected network with 60 nodes, and this average degree how many links do I have? Okay, so they are asking me this value, L. In this case, I'm going to solve it using the definition of the average degree, okay? So if I know that the average degree is, I know, okay, that the average degree is the addition of all the possible degrees, okay, of all the nodes divided by n, which this in turn, this is twice, because this is an undirected network, this is going to be twice the number of links divided by n. So from this expression, I know that L is going to be n times the average degree divided by 2, okay? And for these numbers, I have that n is equal to 60 times 3.9 divided by 2 is 30 times 3.9, which is 117. So these are the number of links. Okay, remember that this is because this is an undirected network. For a directed network, I would have to use these two wouldn't be here. Okay, that would be without the 2. In the next question, they tell me that now G prime is a network where the average in degree is equal to 5 and it has 50 nodes. And they ask me the same, what is the number of links? But they also ask me, what is the average out degree? Now, in this case, since we are talking about in degree and out degree, clearly G prime is going to be a directed network. So remember that in the case of a directed network, okay, I'm going to use the case of a directed network, the average in degree is going to be equal to the average, the addition of all the in degrees of each node divided by n. Now, in this case, since we are only adding the in degrees, okay, so for every node, I'm adding all the nodes, all the arrows that point to this node, okay? So even if if I'm going to count also for this other node, this is not like in the case of an undirected network, where in that case I would be counting this link twice because it is undirected. Now, since this is a directed link with an arrow, then I'm only going to count once each of these links. So this is exactly the number of links, okay? So this is going to be the number of links divided by n. So the number of links in this case is equal to n times this average in degree, which is going to be 5 times 50, which is 250 links. So this is the number of links of this network. And since we know the number of links, then with the same, since I have the number of links, which is this addition, these links can also be interpreted as the out degree of nodes. So the out degree, the average out degree is going to be also the addition of all the out degree of the nodes divided by the number of nodes. And this is by the same reasoning like as before. This is L divided by n. So this means that we have exactly the same out degree on average. So if we know on a network, if we know the average in degree, then they already know the average out degree, okay, because it's the same number. It's exactly the same number. Now in the next question, they're asking me to calculate the density of a directed network. Okay, this is a directed network with this average in degree and n nodes. So since this is a directed network, they are telling me that this is the in degree, the average in degree. As we just saw in the previous question, this number is the same for the in degree and for the out degree. Okay, the average in degree and the average out degree are the same. So that is why they are telling me only with the k and no k in or k out, and n nodes. So in this case, we are going to do exactly the same. Remember that the density is the number of links divided by the maximum number of links that I might find in that network. So the density is going to be equal to L divided by L max. Now, how much is L? Remember that L is equal to the average degree, okay? Because this is the average in degree in this case times n. So this is the average degree times n. This is the number of links, and now the maximum number of links is going to be n times n minus 1. So these two cancel out, and what we obtain is the average degree divided by n minus 1. So this is the density of the network, of a directed network. Now, if instead of a directed network I had an undirected network, then if they gave me the average degree, remember that I can compute the number of links of the network from the average degree by multiplying by n. Okay, but also I have to divide by 2. So this is going to be the average, this is going to be the number of links of the undirected network. And now the density is going to be, remember, L divided by L max. But now L max, it also has this factor of 1/2. So what I find is that I have n times the average degree divided by 2 divided by n times n minus 1 divided by 2. So these two factors cancel out, and these two n's also cancel out, and I have the same expression for a directed and for an undirected network.